Hello students, welcome to my class. Today we are going to discuss few questions related to JEE main exams. Clear? So let's start with the topic, and my first question, look at. In Bosch process, which gas is utilized for the production of hydrogen? Now tell me which one is a Bosch process, which is Bosch process. The question here, as I discussed you, when Coke, red hot Coke, when steam is passed over red hot Coke, then what will happen? There is a formation of water gas take place. Clear what I'm telling? There is a formation of water gas take place, and this water gas again, when treatment with steam, what will happen? There is a formation of CO2 and H2. And how to remove CO2? When pass over water, CO2 will be absorbed in water, but in CO2 there is a small trace of carbon monoxide also. How to remove carbon monoxide? When the mixture is passed through the solution of Cu2 Cl2 ammoniacal, then what will happen next? Next, if small traces also CO2, then it is passed over nickel, and finally we will get pure H2. This is the concept. The question is very simple. In Bosch process, which gas is utilized for the production of hydrogen? Sir, the answer is water gas. It's very simple. Now how to represent the equation, that's matter. Wait for a moment. What I'm telling, listen carefully. That is, first of all, red hot Coke. This is red hot Coke. When steam is passed over red hot Coke, that is H2O, this is steam. Then what will happen? Tell me. It will give you CO plus H2. This is the basis of Bosch process, and this is, friend, water gas. Clear? Now, when the mixture is treated with double of its volume of steam in presence of Fe2O3 or Cr2O3, it will act as a catalyst. The temperature 450 to 500 degrees Celsius. Then what will happen in this case? It will form CO2 plus H2. This is hydrogen. And how to remove hydrogen? It also contains small traces of carbon monoxide also. Now, this mixture, when treatment with water again pass around, the pressure is 25 atm. Then friend, what will happen? This CO2 will be absorbed. Then now it contains a small content of CO and water and hydrogen, Now how to remove this carbon monoxide? It's very simple. Now this mixture CO2, now this mixture is passed through the ammoniacal Cu2 Cl2. Now here what will happen? CO is absorbed. Clear? Now this again pass through nickel. Now we will get pure hydrogen. Clear? This is the complete cycle. What happened? And this process is known as Bosch process, which is used for absorption, for removal of carbon monoxide. First ammoniacal Cu2 Cl2 and then nickel, and finally we get pure hydrogen. This is the complete solution of this question. This question is completely theory based. Clear friend? Now let's move to the next. What I am telling, listen carefully. That is question number 2. Clear? Look at the question. when the same amount of zinc is treated separately with excess of sulfuric acid. What is given here? That is H2SO4, clear? And the next one is excess of sodium hydroxide. What is sodium hydroxide, friend? That is NaOH. Now, the ratio of volume of hydrogen evolved. What the question is telling? The ratio of volume of hydrogen evolved. Whether it is 1:1, whether it is 1:2, whether it is 2:1, whether it is 9:4. First of all, I will give you a detailed solution. Then we will discuss how to get the answer. Clear? I am moving here. Look at and listen carefully. Here is given Zn. When treatment with H2SO4, then what will happen? Tell me. So simple reaction, that is ZnSO4 into H2. Yes, sir. Good. Now, again when Zn is treated with NaOH, then what will happen? We people know it gives you Na2ZnO2 and plus H2. Now balance the reaction. Look at, that is complete balance. 1 mole of H2 and 1 mole of H2. That is the ratio H2 tends to H2. That is 1:1. So tell me, here is the same amount of Zn. So tell me what will happen in this case. Sir, the answer in this case is not 1:2, not 2:1, not 9:4. The better one is 1:1. Am I right, friend? This is the simple solution of this question. This is completely theory based. Before approaching the question, before solving the question, read the question carefully. What I am telling, listen carefully. If you have 1 minute for a question, okay, if you have 1 minute for a question, give 40 seconds to read the question, and I promise you within 20 seconds you will answer the question. This is the concept. But what we do, friend, we give only 20 seconds to read the question and rest 40 seconds to solve the question, because every question has its answer. Every question brings answer. So follow the tips, technique. Before appearing into the examination, you follow my trick during normal practice session. I think it will help you a lot. Clear? Now friend, I am moving to the next question. What will happen? Check it out. Now look at, this is completely calculative type. What is given here? The volume of 10 volume H2O2 required to liberate 500 ml of O2 at NTP. What is NTP? We people know normal temperature and pressure. Now how to solve such question? Look at, here is given 10 volume of H2O2. What does it mean? Listen carefully. I am giving you a detailed solution. That is 10 volume of H2O2 means, tell me, it means, do you remember this? 1 volume of H2O2 gives you 10 volume of O2 at NTP. This is the meaning of the statement. Now, if I write here X ml of 10 volume H2O2, what does it means? It means that X ml of 10 volume H2O2, okay sir, clear, gives X into 10, if I write here ml, X into 10 ml of O2 at NTP. Am I right or wrong? Sir, now you are right. What I have written? X ml of 10 volume H2O2 gives X into 10. If I write here Y, then what will happen? 10 into Y. Clear to you? Now, this is the question, x into 10 ml of O2. Now the question asks, what is x? Clear? What is x? And given here, if x ml of 10 volume gives you 500 ml, that is here x into 10 is equal to 500. Clear to you? Now x is equal to 500 upon 10, that is 50 ml. The answer is 50 ml. Am I right or wrong? Check it out. If I know the 50 ml, if the question is like this, 50 ml of 10 volume H2O2 gives how many ml, how much ml of O2? That is, as we know, x ml gives you x into 10, then put here 50 ml. Then what will happen? That is 50 into 10, that is 500 ml of O2. Look at here, given 500 ml of O2. So this is the complete explanation. Put the answer, you will get the answer. So what I am telling, every question brings answer. Be careful, check out the solution. You can easily solve such kind of solution. Inorganic chemistry is not so boring. It depends how to approach. Clear? Now wait for a moment. Listen carefully. Let's move to the next question. Now the next question is, which of the following reaction shows the oxidizing nature of H2O2? We people know, if I talk about H2O2, then it has oxidizing agent, it will behave as oxidizing agent, and it also behave as a reducing agent. Now here the case which shows the oxidizing nature, that means to say, if there is a decrement in oxidation state, then we can say it is a oxidizing nature. But if there is a increment in oxidation state, then we people say there is it behave as a reducing agent. Now check out. Here I is -1 oxidation state and it forms 0, I2. Here is an increment in oxidation state, that is, it brings oxidation due to the presence of H2O2, that is, iodine has increased in oxidation state. According to the rule, this one is reducing agent, so it is a oxidizing agent. It's very simple. So we can say in this case H2O2 is a oxidizing, act as a oxidizing agent, and it will show the oxidizing nature. Clear to you? One more thing I am going to mention here, this is a single option correct type question. So we do not need to check B, C and D. If you check B, C and D, that doesn't matter, you can easily check out. Look at in this case, here is O2 is -1 oxidation state, but here O2, that is oxygen, is in -1 oxidation state and oxygen is 0 oxidation state. Increment in oxidation state, so it is not oxidizing agent, it is a reducing agent. If I talk about this one only, Cl2 is in 0 oxidation state and here is -1 decrement. So this one is reducing agent and this one is oxidizing agent. Clear? Now next you can also check this question. Look at here. Here silver is in +1 oxidizing agent, +1, and here silver is 0 oxidation state. Now tell me what will happen in this case. In this case, +1 and 0, there is a decrement. If there is a decrement, then it is a oxidizing agent. So this one is reducing agent and we have to find the oxidizing agent, not reducing agent. Again check out this one. Look at here, that is, here the oxidation state is -1 and here the oxidation state is 0. Now in this case what will happen, check it out, that is -1 has increment to 0. That is the increment in oxidation state. If there is an increment in oxidation state, then what will happen? We people know this is the reducing nature. So in this case, H2O2 is a reducing agent. One more concept, if I not looking at this, if I looking at this only, clear? NaClO converted to NaCl, that is the removal of oxygen take place. If there is a removal, then definitely this will behave as a oxidizing agent. This is another concern. If this is a oxidizing agent, then definitely this person, this H2O2 I am treating is a person, which is not a person, it is just a chemical. It will act as a reducing agent. So we have lots of method to assume which act as a oxidizing agent, which act a reducing agent. Do not need to follow my trick. It's not necessary. If you have your own trick, then it's all okay. But what I am telling, theory pattern changes, theory never changes. It remains forever. Clear, friend? So for this, what is the correct option? This 3 shows that the reducing nature, but this A option shows the oxidizing nature of H2O2. So this is the correct option. A is the correct option for this question. Clear, friend? Now let's move to the next one. Hydrogen react with the following in the dark. These all are halogens. Do you know what will happen? Yes, sir. When hydrogen on treatment with Br2, it form HBr. When treatment with F2, it form HF. When treatment with HI, it form when treatment with I2, it form HI. When treatment with Cl, it form SCl. But as we know, F2 is more reactive than chlorine, than bromine, than iodine. So hydrogen will react in dark, that is there is no requirement of any initiating agent. So in this case, what will happen? Which one is more reactive? So fluorine, high electronegativity. Do you remember this? So hydrogen do not require any initiating agent to react with fluorine. So the answer will be B, fluorine. Clear to you, friend? Now this question is completely theory based question. It do not require any calculation. It just require to go through the syllabus, to go through the chapter. Okay, friend. Now let's move to the question number 6. The process used for the removal of hardness. First of all, tell me what is hardness. Hardness, that is those water which do not form leather. Sorry. What I am telling, those water which do not form leather with soap are known as hard water, which form leather easily are known as soft water. What is the reason of hardness? Due to the presence of bicarbonate and chloride and sulfate of calcium and magnesium. There are 2 types of hardness. Do you remember this? First one is, tell me, sir, the first one is temporary hardness. The second one is permanent hardness. What is temporary hardness? It is due to the presence of bicarbonate of calcium and magnesium. It is very easy to remove the temporary hardness by simple boiling. This is the best method. Now, if you want to remove the permanent hardness, then what to do? Various method, by using washing soda also, Calgon process, permutate process, ion exchange resin process. Remember? Now, look at here. As I told you, the process used for the removal of removal of hardness of water is Calgon. What is the formula of Calgon? This is a question from my side for you. Tell me what is the formula of Calgon. I forget, friend. You have to help me. Think on it. What is Calgon? Sir, Calgon is sodium hexametaphosphate. What is sodium hexametaphosphate? How to write the formula? Do you remember this? Sir, Na2, Na4, PO3 whole 6. This is the formula of Calgon. Clear? Remember, sodium hexametaphosphate. Now I'm going to rub this part, friend, and we'll discuss the next part of the question. Wait for a moment. and listen carefully. In which of the H2 act as a reducing agent? Here not oxidizing agent. Here definitely we have to observe the, now as we people know what is reducing agent, if there is an increment in oxidation state. So how to check? If you do not, if you need to check H2O2 is all okay. If you do not need to check H2O2, it doesn't matter, you can check this all also, and you can easily assume whether H2O2 will act as an oxidizing agent or reducing agent. Now check it out, but I am giving you a clue. I am not checking this one, whether there is an increment or decrement. I am checking this. As here Pb is in +4 oxidation state, yes sir. Here is Pb is in +2 oxidation state. There is a decrement in oxidation state, yes sir. If there is a decrement in oxidation state, then what will happen? PbO2 is a oxidizing agent, then its friend H2O2 will act as a reducing agent. Clear? So we do not need to check B, C, D because single option correct type. So definitely the answer will be A, but you can also check the other option also. Here look at what is the case of sulfur. Sulfur is in +4 oxidation state. Here the sulfur is in +6 oxidation state. Clear to you? There is a increment in oxidation state. Am I right or wrong? Yes sir, you are right. Check it out. +4 to +6. There is an increment in oxidation state. If there is an increment in oxidation state, then it will behave as a reducing agent. Am I right or wrong? So you are right. Now, and here if it behaves as a reducing agent, then it will behave as a oxidizing agent. Now one more thing, I have to check it +4 to +2 decrement, that is a reducing agent, oxidizing agent, and this one is reducing. Now check out this one. As I discussed earlier, here is I is in -1 oxidation state and this one is 0. Definitely there is an increment. So this one is reducing agent, so definitely this one is oxidizing agent, and we need to find the reducing agent. So we do not need to check more option, you can easily find out. You can say sir, A option is the correct answer. Clear? Now I am going to rub this part friend and we'll discuss the next part of the question. Wait for a moment. Now the next question is, this is the complete theory as well as calculative. During my lecture, I have derived the entire calculation. Now the question is H2O2 is 5.6 volume. Then what is? It is 1.7% weight by volume. It is 1 normal. Both are true, none are true. Clear? Now moving here, look at what I am telling. Do you remember this? Volume strength. Volume, what is volume strength? So volume strength is equal to 5.6 into normality. Am I right or wrong? Sir, you are right. And in terms of molarity, what is volume strength? Sir, volume strength is 11.2 into molarity. As I discussed earlier, I have derived during my lecture. Now, here the question, the volume strength is given 5.6 according to the question, I am not saying, equal to 5.6 into N. Clear? So, what will happen? So, that is normality is equal to 5.6 divided by 5.6 and this will cancel. What will happen? 1. If there is a 1 normal, then the percentage, remember this, 1.7%. So, which is the correct option? So, A and B. But this is a single option type question. So, look at both are true. Pardon friend, this one is B option, this one is C and this one is D option. Clear to you? So, we can say it is 1 normal, it is 1.7% weight by volume. So, the answer is both are true. What will we say? Sir, in A, B, C and D, C option is correct. Both are true. Now I'm going to rub this part, friend, and we'll discuss the next part. Wait for a moment. Okay, now let's move to the next one. Look at, out of the following metal which will give H2 on reaction with NaOH. This is your turn, tell me. I think you are very much familiar with such type of reaction. As we know, if I talk about zinc, Na2ZnO2, zinc on treatment with NaOH. If I talk about aluminium, NaAlO2. Remember this. If I talk about beryllium, there is also reaction possible. But if I talk about Mg, there is no liberation of hydrogen take place. In this case, what will happen? Which will give you H2, that is Zn, that is Al, and that is Be. Be. Why Be? Because beryllium has a small diagonal relationship. Otherwise, Be also belong to the second group. Mg also belong to the second group, that is the alkaline earth metal. So there is no possibility of the treatment with NaOH. This is the strong alkali, and this alkali comes from alkali metal. Na is the alkali metal, but beryllium has slight diagonal relationship with aluminium. Do you remember? Due to this reason, it will have slight equal property, or you can say it will have similar property with aluminium. Due to this reason, ZnAl definitely gives H2 and also beryllium. So this one is slight confusing. Sometimes we people think that A and 3 is the correct option, but look at beryllium here, again I am repeating, and aluminium are diagonally related to each other. There is a relationship. So beryllium also give the same reaction as aluminium give. So in this case we say Zn, Al and B, that is 1, 3 and 4. So D is not a correct option. Better this is a correct option. So what I am telling, friend, before choosing any option, first of all read the question carefully, then you will get the correct answer, because we are giving competitive examination, not board examination. There is very less chances to what I am telling, there is very tough competition and very less chances of error. If you commit any mistake, then friend, what will happen? You will not qualify the examination. Clear? Now let's move to the next question. What is the next question? Listen carefully. Out of LiH, MgH2 and CuH, as we know, LiH, Mg, which are ionic, covalent. As we know, if I talk about the hydride of hydrogen, first one is ionic hydride. Generally it forms with alkali metal and alkaline earth metal, but there is an exception. Do you remember this? Beryllium and magnesium. Beryllium hydride and magnesium hydride are not completely ionic, but lithium hydride is completely ionic because it belongs to alkali metal series. But the next one is covalent hydride, and the third one is, best one is, that is interstitial hydrides also. So in this case, choose which one is the correct. All are ionic hydride, not possible. LiH is a ionic hydride, but MgH2 is not a complete ionic hydride. It has slight covalent character, and CuH also. Now LiH, MgH2 are ionic, no. CuH is covalent, no. This one is wrong, and this one is also wrong. Now the all are covalent, not possible, friend. This one is also wrong answer. Now look at the next one. Yes sir, LiH is ionic, okay. Then MgH2 and CuH2 are intermediate. These are partial ionic and partial covalent character. This is the correct explanation. Do you remember these questions? So what we get from these questions, we find that for this chapter, that is, some questions are calculative type, Very few questions are calculative type, and most of questions are completely conceptual, theory based. So boost your knowledge with solid theory, then you can easily solve such kind of questions. Wait for a moment, I am reviewing the question. Now give the answer. Sir, this one is water gas. Now just memorize. I am not telling them memorize, just solve lots of time, then definitely you will get the answer very easily. So water gas, this one, sir, 1:1, then this one, sir, 50 ml, that's good. Sir, A option, that's good. Sir, F2, that's good. Then sir, Calgon, A option, okay. Now this one, sir, A option, that's good. Smart work. Now this one, sir, this one is A, B, C and D. Sir, C option. Okay friend, that's good. Now tell me which one. Sir, as you told, 1, 3 and 4. Sir, B option. Okay friend. Now this one, tell me, sir, D option. So practice makes a person perfect. If you have any doubt related to the chapter hydrogen and its compound, related to any question, then you can easily approach to me. As I told you, as I promise you, I am always here to serve you. So friend, time is calling, so it's time to say you bye bye. Thank you so much. We will meet again.